And so our next speaker is Head of Innovation. His name is Yannis Perrakis from Temenos. So Temenos is one of the major providers of banking software infrastructure in the world. They provide banking software from all the range from lower tier banks all the way to Metro Bank and more. We've been working with them for most of this year on integration with Flowers, so to bring some of these federated learning capabilities to the financial sector. And it's really been a pleasure working with them so closely to enable these types of features. So with that, hand over to Yannis.
Thanks, Nick. Hi, everyone. I'll just maximize this. Okay, cool. All right, so I'll get right to it. So a couple of words on Temenos very quickly. So as Nick said, so Temenos is the market leader in banking software, what we call core banking in the main. So basically everything that runs a bank. So if you have an account, if you have a credit card, a loan, a mortgage, etc., that's what we underpin. Generally, you can see some of basically the stats here, but the one that I think is interesting is that 1.3 billion of people globally, that's about a third of the world's banked population, are banking on Temenos, even though they don't know it. So we are a B2B, if you like, company. We sell our software, our functionality to banks, and then they build their bank on top of it. So if you look around, if there's you look to your left, to your right, probably one of the three of you is banking on Temenos, even though you don't know it. So there's quite a large and horizontal footprint. A lot of that is in the retail space, so the type of banking services that we use as individuals, but then there is corporate banking, banking for SMEs, small and medium-sized enterprises, but also wealth banking and some of those more specialized services. Plus things like financial crime, compliance, fraud prevention, all of those areas that are important to banks. So that's Temenos. I think here everyone knows about Flower, but what's interesting is what can you do if you combine the two forces together? Because with the very large and very horizontal footprint that Temenos has, we think that we are very well placed to develop and deploy federated learning for this type of financial use cases that you see here at really global scale. So our hypothesis here is instead of, which you can also do, but instead of going and trying to convince a single individual bank to go around, gather another, say, 10 banks and try and improve, say, their credit worthiness or their fraud prevention type of model by building some sort of consortium and then technically implemented federated learning, our hypothesis is that Temenos can do that on their behalf because all of those banks, more than 1,500 globally, already bank and already have their software and in many cases their data and their transactional data on Temenos. So that's what we're setting out to explore. I should say we're pretty early stage, so we completed a couple of phases. The one that we're talking about here is a POC that is now starting to move towards more of a pilot. So what did we try to do? We basically, we picked the example of a retail credit worthiness data set. So basically being able, from the perspective of the bank, to understand if somebody is going to ask for a loan, how credit worthy is that application. And obviously banks today do this at an individual, centralized, in sort of in the nomenclature that we're using here today way. So our hypothesis here is that if you were not to do that in this very siloed way, but if you were to build a model that takes advantage of that, both larger from a quantity perspective, but also from a variability and a heterogeneity type of perspective data set, or rather build a model on top of that type of data set, you should get higher accuracy, which could benefit all of those banks. So that's what we've done. In a nutshell, we've run a series of experiments, trying to experiment with different ways to simulate those different banks, and that's what I'll show you here. This is a very basic deployment infrastructure. I think this should be familiar to most people here. So we have basically a Flower super link. This is what Temenos would host in effect. And then you have the super nodes, which are simulating what would individual banks host. Now I'm going to go to the demo. Let's see if you can hear this.
For this POC, we are taking a curated...
Yes, it's here. Okay, so that's
Federated Lending Club dataset from XAI for creditworthiness in retail banking. The dataset will be split. For each of the three scenarios, and from each partition, an 80-20% split will be uploaded to cloud storage used to train and test both locally and federated. The performance measurement will be area under curve, AUC. The first scenario is to split the dataset into 4 random partitions. For the second scenario, we will split the dataset on the top 4 US states of the customers. So, partition 1 is California, 2 is New York, 3 is Texas and 4 is Florida. For the final experiment, we will split the dataset into 8 partitions randomly. In federated learning, there is typically one server, and several clients connected to the server. This architecture is often called a federation. The server's role is to coordinate the overall federated training process, while each client receives training tasks from the server, executes them, and returns the results. In our proof of concept, the Flower server process is called a superlink, and the Flower clients are known as supernodes. As shown in the previous slide, we have pre-split the dataset into segments, with one file for each node in the experiment. These are uploaded to an Azure Blob Storage account. We have created containers for both superlink and supernodes, which are stored in the Azure Container Registry, ACR. We are using Azure Kubernetes Service, AKS, to host these containers, as it allows us to easily spin up the supernodes needed for our experiments. The ACR is connected to the node pool, and an AKS ingress service allows a data scientist to send experiments to the superlink server. When the stateful set pods for the supernode start up, they pick the correct dataset split file from Azure Blob Storage to process. In this demo, we will show the standalone and federated experiments followed by the results. We partitioned our datasets into 3 distinct configurations, 4 randomly generated partitions, 4 state-based partitions, and 8 randomly generated partitions. These partitioned datasets were then uploaded to Azure Storage. Standalone tests were executed for each partition across all 3 datasets. This involved training and evaluating a model on each individual partition, followed by a comprehensive evaluation using test data from the remaining partitions. The observed performance decline with larger, cross-partition test data suggests that federated training may offer a more effective approach to develop a robust model applicable across all partitions. Next, we will demonstrate the federated training over each of the 3 configurations. We have an AKS cluster which is hosting 1 superlink server and 4 supernodes as shown on the left pane. The first experiment refers to the configuration with the 4 randomly generated data partitions. The experiment is run over all the deployed supernode pods. On the left pane, we are showing the training process, and on the right pane the results. The first set of results show the aggregated result for each round. The second set of results show how well the federated model performed on each partition during each round. The final result is the highest performance from each partition over the 20 federated rounds. A conclusive visualization of all 3 configurations' results is shown later in the presentation. We will now show the federated run of the 4 states in the US. As previously, we have the 2 sets of results. For the 8 random split, we first need to add the 4 extra pods in Kubernetes. Now we start the federated run. Here we can see the results. As you can see in the second section, we have the 8 results. 1 per partition per round, with the highest performance for each partition shown in the last round. Here are the results from the 4 randomly generated partitions. The red column shows the best AUC score of the standalone model against each bank's test data, and the green column shows the best AUC of the federated model against each bank's test partition. As you can see in this scenario, the federated model demonstrates the best performance. Here are the results for the 4 US state partitions. Again, this shows that the federated model exhibits the best performance against the test set of each state. Here are the results from the 8 randomly generated partitions. In almost all cases, the federated model outperforms the local model. The AUC score of the red column represents the slightly optimistic scenario where all banks can share and gather their data into a centralized repository and train and test a centralized model. The green column shows the best AUC score achieved by the federated model for each configuration. As it also evident here, the federated model performs better or on par with the centralized model, demonstrating the capability of federated learning to efficiently learn in highly constrained, private and secure training environments, where data needs to remain private.
Back to the presentation. So yeah, so as I said, do I need to switch it to go back to the, sorry. Okay, yeah, so as the video showed, as I said, it's still early days, but I think the results are quite promising. So what's the next step here? So beyond doing this with synthetic data sets from what Temenos already has, so our next step is to now start testing out and experimenting around this with some of our banking customers. As part of this, Temenos does also have a large partner exchange. So these are Temenos partners, and there's more than 120 active partners and almost 200 products now in the exchange. So we're happy that Flower is going to be joining the exchange, and together we'll be able to go to some of our banking partners and explore this in more depth. I think in the long term, the potential here is very large. As I said, Temenos is probably the most horizontal company in the world today in terms of banking software, and the hypothesis is that federated learning can benefit pretty much our entire customer base ultimately. That's it from me. Thanks for watching.
Thanks very much. We've got time for one quick question, and the question comes from that gentleman in the back.
Thanks for the presentation. Are you aware of WeBank in China? They've been doing kind of exploring the use of private set intersection and federated learning in the financial sector. So are you planning to do something different?
Yeah, so maybe a couple of things. I think first of all, I mean, as I think the audience here can appreciate, federated learning is one in a family of privacy preserving technologies, and from a Temenos perspective, we are looking at a number of things, including homomorphic, zero knowledge, secure multi-party computation, some of the themes that we've been talking about here for different use cases. What you also see in certain sort of region and geographies around the world is banking consortia that try to develop frameworks like this. And this goes to what I said in the beginning, that if you're an individual bank and you're trying to take advantage of those types of technologies, part of the heavy lifting that you need to do is put together not the technology, but like a logistical and a governance framework for how you're going to collaborate with other banks in a secure and a sort of privacy-preserving way to build, say, a better model like this. Right? So this is something that banks can do, and in certain places there's a consortium like that in the Netherlands, for example, that is pretty active. What we're trying to do here is to say we we are going to do all of that heavy lifting for you because those banks are already Temenos customers. So it's not like they need to come to us, they're basically here already, if you like. So it's more of a case of basically deploying the technology to them rather than having to come to a new solution that they're not using already. That's how we think we can make this more frictionless for them. Yeah.
Great. So thank you again, Yannis. Thank you.